All right, welcome. Today, we're going to unlock a set of mathematical superpowers. They're called algebraic identities, and you can think of them as secret codes that turn these long, messy calculations into simple, elegant answers in like a single step. So let's dive in. You know that feeling, right? You're multiplying expressions, you're lost in a sea of terms. It's so common. You follow all the steps, but it just feels clunky and slow. Well, what if I told you there's a much smarter, way faster way to get to the answer? So here's our game plan. We're going to level up our skills in 5 stages. First, we'll quickly go over the standard way of multiplying. Then we unlock our first shortcut. We'll master the power of squares, level up to cubes, and then, my favorite part, we'll see these things out in the wild. Now, before we can really appreciate the shortcuts, we gotta lock down the foundation. So let's start with the direct multiplication method. You know, the one you probably learned first in school. It's our baseline, and it's the path we're about to make a whole lot faster. Yeah, this is what I'd call the brute force method. You take each term in the first parentheses and multiply it by every single term in the second one. I mean, look at this example. It works, for sure, but it creates so many extra steps before you can simplify it all down. There's gotta be a more elegant way, right? And of course, a super common way to remember this is the acronym FOIL. Multiply the first terms, then the outer, the inner, and finally the last terms. It's great for staying organized, but it's still 4 different multiplications plus a whole extra step just to combine the like terms. All right, it's time for our first real power-up. We're about to unlock our first algebraic identity. An identity is really just an equation that is always true, no matter what values you plug into it. And because it's always true, well, we can use it as an amazing shortcut. Okay, now this is where the magic happens. On the left, we're using the old FOIL method, but notice something really important. The middle terms, minus 20xy and plus 20xy, they just cancel each other out. The shortcut on the right knows this is going to happen, so it skips right to the end. It just jumps directly from the problem to the answer. One clean step. And that brings us to our first official identity. From now on, whenever you see this pattern, the exact same 2 terms, one pair added and one pair subtracted, you don't have to multiply everything out. You just square the first term, square the second term, and stick a minus sign in between. Simple, powerful, and so much faster. Okay, with that first shortcut in our back pocket, let's add 2 more absolutely essential tools to our kit. These identities are all about what happens when you square a binomial. That's just an expression with 2 terms, like a plus b. This is one of the most common things you'll see in algebra. So here's the square of a sum. Now, a really, really common mistake is to think a plus b squared is just a squared plus b squared. It is not. You're missing that crucial middle term, 2 times the product of a and b. So the pattern to burn into your brain is square the first term, square the last term, and then add twice their product right in the middle. And its twin is the square of a difference. The pattern is almost identical. You square the first, you square the last. The only change, the only one, is the sign of that middle term. It becomes minus twice the product. That one little sign is the only thing you have to remember. Let's see it in action here. To expand this, we just apply the formula. Our a is 3x and our b is 4y. So we get 3x squared, which is 9x squared, plus 2 times 3x times 4y, which is 24xy, plus 4y squared, which is 16y squared. No FOIL needed, just a direct application of the identity. You've totally mastered squares, so you are ready for the next challenge. We are now taking our shortcuts from the second dimension into the third dimension by looking at cubes. I know, this one looks a little intimidating at first, but there's a beautiful logical pattern here. For a plus b cubed, just watch the powers. The power of a goes down, 3, 2, 1, then none. At the exact same time, the power of b goes up, none, then 1, 2, and 3. And the numbers in the middle? They're both 3s. Once you see that pattern, it's so much easier to remember. And just like with the squares, the pattern holds for the cube of a difference. The terms are exactly the same, but the signs just alternate. Positive, negative, positive, negative. Once you see the patterns, these big formulas become way less intimidating. So, we've got all these amazing shortcuts. But are they just for your algebra class? Absolutely not. Let's see how these abstract rules become awesome tools for solving real problems, even mental math. Okay, here's the challenge.
no calculator, how would you figure out the product of 107 and 93? Seems pretty tough to do in your head, doesn't it? But what if we look at it through the lens of our very first identity?
The whole trick is just spotting the pattern. 107 is just 100 plus 7, and 93 is 100 minus 7. All of a sudden, this isn't a hard multiplication problem anymore. It's our old friend, the product of a sum and a difference. And now the solution is incredibly simple. We just square the first term. 100 squared is 10,000. And we subtract the square of the second term. 7 squared is 49. 10,000 minus 49 is 9951. You can do that in seconds, all thanks to that identity.
And their power goes even further than that. In algebra, you can use identities like puzzle pieces. For instance, if you know what a plus b is, and you know what a times b is, you can actually use an identity to find a squared plus b squared without ever solving for a and b themselves. It's a really clever way to find unknowns.
So here it is, the ultimate toolkit we've built today. These are the key formulas to have in your back pocket. They're your shortcuts, your problem-solving power-ups. Don't just see this as a list to memorize. See it as a set of keys that unlock faster, smarter ways of thinking about math. You know, the real skill is learning to spot when you can use these tools. So I'll leave you with a final challenge. How would you calculate 98 squared in your head? Instead of multiplying the long way, look at it differently. Which one of our new identities turns this into a simple two-step problem?